आदित्य शंकर absent, अनुप रंजन, भवानी शंकर मिश्र. Am I audible? Am I audible? Ipsita?
Yes, sir.
Yes, sir.
Okay. So, Bhavani Shankar Mishra, Binori Baral, Biswajit Rana, Dhananjay Das, Jagdish Khillar, Jiban Jyoti Jena, Jyoti Amrut Malik,
Present, sir.
Jyoti Amrut present. Radip Mohanty, Roshan Kumar, Rupali Sahu,
Present, sir.
Rupali present. Last class absent. Rupali?
Yes, sir.
Okay. Saurav Mohanty.
Present, sir.
Okay. Srinivas De. Shubham Kanungu. Subhasmita Behera. Shetalin Priyadarshini. Khitish Kuntia.
Present, sir.
Khitish present. Padmanav Samal. Pratyasha Mishra. Sai Divyakant Nayak. Sheikh Adil. Aditi Sahu. Anshuman Nayak. Chetana Jyoti Maharana. Gaurav Prasad Das.
Present, sir.
Gaurav Prasad present. Om Prakash Sahu. Absent. Rashminandan Sahu electrical. Saubhagya Patra. Tushar Ranjan Sahu. Abhishek Acharya.
Present, sir.
Present. Kali absent thilo?
Yes, sir.
Arnada Shankar Tripathi. Absent. Arthur Das. Babul Naik. Bhavani Shankar Bala. Chinmay Pradhan.
Present, sir.
Chinmay Pradhan present.
Yes, sir.
Chittaranjan Behera absent. Gaurav Behera. Gulshan Bari. Ipsita Das
Present, sir.
present. Malay Rautray absent. Mujahid Khan. Mrutyunjay Dani. Piyush Kumar
Present, sir.
present. Rashmirandan Sahu. Electronics Rashmirandan Sahu absent. Sagarika Swai absent. Sajan Kumar.
Present, sir.
Sagarika
present.
present. Sajan Kumar absent. Satyaprakash Swai absent. Sheikh Furkan, absent. Sumant Barik, absent. Sostri Vandita Das, you were absent yesterday. Sostri Vandita,
Yes, sir.
खाली absent थिलो ता आगो क्लास absent
Yes, sir.
अभिषेक बेहरा,
Again, sir.
Present, sir.
okay. अभिषेक प्रेजेंट. देवाशीष बेहरा, देवाशीष absent. इमरान मिर्जा, absent. कैबल्य प्रधान, करण
Present,
कुमार
sir.
बेहरा, कैबल्य प्रेजेंट. कैबल्य प्रधान,
Yes, sir.
करण कुमार बेहरा, absent. क्षितिश विश्वाल, absent. ललितादित्य, मनीष कुमार गुप्ता,
Present.
प्रेजेंट. मोहन चुली,
Present, sir.
मोहन प्रेजेंट. पीयूष प्रियांशुनाथ,
Present,
प्रियांशु
sir.
प्रेजेंट. रोधी सुंदर रथ, absent. स्मृति रंजन जेना, absent. शुभम बारिक, absent. स्वागत प्रहराज, absent. किसी क्लास करना ना कौन. ओके.
Hello. Sir.
सजन
Sir,
बोलो.
224, Sajan Kumar, sir. Yes, sir. So, network issue था.
224 सजन कुमार. अच्छा.
Yes, sir. भवन शकर. Sir, बोलो. 224, sir. Sir. भवन शकर बोल sir. 212.
212
Sir.
भवानी शंकर बल. हाँ. Yes, present भवानी. Then any of you?
Sir, 237.
237 मनीष गुप्ता पढ़ी. Given. Okay, now all of you go through the PDF I have provided to you. Okay. Today we'll discuss about DC machine. Okay. Now open the PDF. DC machine. All of you open the PDF. कैबल्य. कैबल्य ओपन कलो. Have you opened that PDF? All of you see. All of you see the PDF. Working principle of DC motor. Okay. Your DC motor is a DC machine. Okay. DC motor is a DC machine, or we can say dynamo. Why it is called a dynamo? Because the EMF induced motionally. Okay, DC motor is a dynamo where the EMF can induce Emotionally. Okay. Manish Kumar Gupta. Manish Gupta. Manish. Am I audible, Manish?
Yes, sir.
You have not appeared the mid-sem exam 1. Had you appeared? Your result showed that you were absent in that exam. Basic electrical, you were absent. Manish?
Yes, sir.
So that will treat as absent.
Yes, sir. Yes, sir.
Why you have not appeared? Why you did not appear? So you meet your
Exam nahi diya, sir.
you meet your HOD, okay?
Yes, sir.
Because that will absent means you will get less mark. Huh?
Yes,
I
sir.
found you have not appeared, so your mark is absent. Okay. So here you see principle of DC motor. Okay. Generally we know DC machine having construction like this. Okay. All of you see the PDF. Okay. North pole, south pole, north pole, south pole. Figure 4.35. All of you see. This is a 4-pole DC machine motor. This is a 4-pole DC motor. North pole, south pole, north pole, south pole. Mohan Choli. Mohan Priyanshu Nath.
Yes, sir. Yes, sir.
ए चित्रटा देखि पारछो? Have you seen?
Yes, sir.
Yes.
Jare kuch.
Okay, now you see figure 4.35. Okay, this is a 4-pole DC machine. How many poles are there? 4 pole. North pole, south pole, north pole, south pole, like this. Okay. Here lines of flux as per the properties of magnets, always lines of flux from north pole to south pole. Yes or no? North pole to south pole, north pole to south pole, likewise. So in between your pole pieces, your armature is rotating. Okay. Here you see, this is DC motor means what? Electrical energy converted to mechanical energy. We have to provide electrical and we will get mechanical. Okay, once we provide electrical, once we provide electrical energy to this DC motor, below you see DC machine with 4 pole, 4.35. Priyanshu.
Yes, sir.
এটা দেখি পারছো?
দেখুଛି sir.
देख 4.35 बी रे कौन लिखा है कहल?
DC machine with 4 pole.
DC machine with 4 pole. Okay. So this is a DC machine. Okay, consisting of different components are there. Okay. If we construct a DC machine, we require main pole. Main pole ko guda north pole, south pole, north pole, south pole. These are your main pole. Okay. And in between pole pieces, you can find middle one is your armature. Okay. First you see, first one what written? Field winding. Field winding means main pole. Okay. Main pole, north pole is there, and some windings are wound over the pole pieces. Okay. So this will be field winding. Okay. And this is your pole shoe. Below that you see pole shoe. Pole shoe mane kono? Horseshoe pole type. Horseshoe pole means ଅଶ୍ଵ ଖୁରାକତି ଚୁମ୍ବକ. Horseshoe pole type. ପ୍ରିୟାଂଶୁ ବୁଝି ହେଉଛି? ये जो देख यहाँ कह पोल शू माने फील्ड वाइंडिंग जोटा लगिला से कौन कह पोल शू ओके
Yes, sir.
एंड यू सी नॉर्थ पोल इज देयर अनदर साउथ पोल ऊपरटा है नॉर्थ पोल लेफ्ट साइड साउथ पोल एंड बॉटम
Yes,
वन
sir.
इज नॉर्थ पोल एंड राइट साइड इज साउथ पोल दैट मीन्स योर आर्मेचर इज रोटेटिंग इन बिटवीन पोल पीसेस clear in between your armature here you see in between your armature जोटा मझे बोलूँ आर्मेचरटा कौन कह आर्मेचर इज द रोटेटिंग पार्ट ऑफ डीसी मशीन क्लियर आर्मेचरटा कौन कहली आर्मेचर
Rotating
इज
part of
द
DC.
रोटेटिंग पार्ट ऑफ डीसी मशीन ओके सो आर्मेचर को देखो आर्मेचर कौन कौन अच्छी सैफ्ट अच्छी ब्रश अच्छी व्हाट इज द रोल ऑफ ब्रश फंक्शन ऑफ ब्रश इज जस्ट टू कलेक्ट करेंट फ्रॉम कंडक्टर ओके ये जेहेतु बाहर सप्लाई दिया ताले इलेक्ट्रिकल एनर्जी कन्वर्टेड टू मैकेनिकल एनर्जी हम नहीं so when this armature we are giving supply to this आमे कौन कहवा वर्किंग प्रिंसिपल ले whenever a current carrying conductor placed in the magnetic field a force will experienced by the armature conductor clear when a current carrying conductor ये जो आर्मेचर टा जोटा बुलूची ओके आर्मेचर इज द रोटेटिंग पार्ट ऑफ डीसी मशीन ओके and whatever that is rotating armature okay if we will take the analysis so we are flowing the current through the armature winding okay once current will flow through the armature winding okay which placed in between the pole pieces in the uniform magnetic field okay a force will experienced by the armature conductor and force into perpendicular distance is your torque so torque will be produced clear how electrical energy converted to mechanical energy so middle one is rotating you see the different components of DC machine field windings is there pole shoe air gap brush shaft okay armature core commutator positive negative yoke of frame so DC machine with 4 pole this is a DC machine with 4 pole system mohan chuli mohan manish gupta manish कैवल्य प्रधान having seen this figure can you recognize how these are connected that means your armature is rotating in between pole pieces okay your armature is rotating in between pole pieces you see outer frame everything is written yoke means what it देखो ये yoke लिखा है upon written yoke or frame yoke provide mechanical support to the entire machine अभिषेक बेहरा मैकेनिकल अभिषेक देवाशीष बेहरा स्वस्त्री बंदिता
Yes, sir.
ये चित्र देखिए नहीं
Yes, sir.
ओके ये चित्र कौन कौन लिखा है कहल पढ़ी चल ये जो डीसी मशीन विथ 4 पोल एटा केते नंबर फिगर स्वस्त्री बंदिता
Yes, sir. सेटा होची 4.35 फिगर.
Yes, very good. This is figure 4.35b. Okay.
B.
Okay, very good. ऊपरटा है 4.35a 4 pole DC motor. Okay. It actually how the winding etc done. এটা डायरेक्टली इनसाइड सब देखी ये जो आउटर फ्रेम जो राउंड हो रही ब्लैक से कौन योक योक और फ्रेम योक्र काम कौन प्रोवाइड मेकानिकल सपोर्ट टू द एंटायर मशीन फंक्शन ऑफ योक इज प्रोवाइड मेकानिकल सपोर्ट टू द एंटायर मशीन आर यू गेटिंग माय पॉइंट शास्त्री बंदिता
Yes, sir.
योक्र काम कौन providing mechanical support to the entire machine माने पूरा मशीन टा को कवर हो रही है कौन कह योक आउ कौन कौन लिखाई कह पढ़ी चलो
लिफ्टिंग आई फील्ड विंडिंग
गोटे गोटे देख लिफ्टिंग आई माने कौन माने देखियो गोटे मोटर जेनेटर उपरे आम लैब जो अच्छी मोटर जेनेटर ओके ऊपर गोटे हुकिंग सिस्टम थी हुकिंग सिस्टम कहीं सपोज यू विल फाइंड ए बिगर साइज मशीन सो हाउ विल डिस्प्लेस फ्रॉम वन प्लेस टू अनदर सपोज वन मोटर इज इन प्रॉब्लम ओके सपोज ए मोटर इज नॉट वर्किंग सो हैव टू टेक दिस मोटर फ्रॉम दिस प्लेस टू दैट प्लेस फॉर रिपेयरिंग सो हाउ टू लिफ्ट अप सो दिस इज योर लिफ्टिंग आई अरेंजमेंट मान जो गोटे हुक लगे ऊपर को नहीं हेब क्रेन साहाय्य okay with the help of crane you can lift from this place to that place so it is lifting eye another kon achi field winding mane north pole south pole okay how many poles are there 4 pole okay so always we can find even number of pole always we can find even number of pole बुझीगला शस्त्री बंदिता
यस सर
आम सब कौन पाइबा सब इवेन नंबर ऑफ पोल्स ओके
सर योक टा कौन टिके आउथरे कहि देबे
योक काम हला प्रोवाइड मेकानिकल सपोर्ट टू द एंटायर मशीन आम सपोज नॉर्थ पोल रहा नॉर्थ पोल साउथ पोल सो थ्रू बोल्ट अरेंजमेंट नॉट बोल्ट जो आंटनी डू यू नो नॉट बोल्ट नॉट बोल्ट जो ताले आम 4 पोल टा नॉर्थ पोल लगे देले कनेक्टेड टू द ओके टू द फ्रेम योक एंड वी कैन ओके स्क्रूड नॉट बोल्ट अरेंजमेंट सो दैट दिस विल फिक्स्ड नो डिस्प्लेसमेंट एसेट्रा नो डिस्प्लेस सो योक फंक्शन है प्रोवाइड मेकानिकल सपोर्ट टू द एंटायर मशीन तन योक इज ए फ्रेम क्लियर these north pole south pole these are the pole pieces or main pole pieces which can be connected to the yoke or frame and function of yoke is provide mechanical support to the entire machine clear these are the field winding means because we know from your magnetic circuit how mmf can develop magnetomotive force how magnetomotive force can develop due to n number of turns and I amount of current flowing through that mmf magnetomotive force which is nothing but product of number of turns into current unit is ampere turn yes or no unit is what ampere turn number of turns into current ampere turn so mmf can develop and a function of mmf is drives flux in a magnetic circuit तेणु नॉर्थ पोल साउथ पोल रहा माने लाइन्स ऑफ फ्लक्स फ्रॉम नॉर्थ पोल साउथ पोल yes or no lines of flux we can find from north pole to south pole likewise okay another pole show horse show pole type अश्व खोराकृति चुंबक horse show pole type Okay, and in between your field winding main pole and your armature. Armature ta kon? Armature is the rotating part of DC machine. Middle one we can say armature. ଏଠି କ'ଣ ଲେଖା ହେଇଛି? ଆର୍ମେଚର କୋର୍। ରାଇଟ୍ ସାଇଡ଼୍ ଦେଖ କ'ଣ ଲେଖା ହେଇଛି? ଆର୍ମେଚର କୋର୍। ସୁଶ୍ରୀ ବନ୍ଦିତା, ହ୍ୱାଟ୍ସ ମେନସନ୍? ଆର୍ମେଚର। ଆରେ ଏପଟେ ରାଇଟ୍ ସାଇଡ଼୍ କ'ଣ ଲେଖା ହେଇଛି? କମ୍ୟୁଟେଟର ବିଲୋ ଦ ଆର୍ମେଚର କୋର୍। ତାହେଲେ ଆର୍ମେଚର ଇଜ୍ ଦ ରୋଟେଟିଂ ପାର୍ଟ ଅଫ୍ DC machine. Because your generator motor is a rotating device, so middle one is your rotating, that is we can say armature. Clear?
Yes, sir.
Armature is the rotating part of DC machine. So this is your armature core. Another you see, another is your commutator. Above armature what written? Commutator. Commutator always fixed to the armature. Commutator always fixed to the armature. While armature is rotating, commutator is rotating along with armature. Okay, commutator always fixed to the armature. Commutator ame kahi lagauche? Because you see, when EMF generated is alternating nature, using commutator, okay, commutator other name we can say split ring, SPLIT, split ring. So using commutator we can get AC to DC, unidirectional. Okay, that's why the name called so DC generator or DC motor. Okay, another brush. What is the function of brush? Function of brush is just to facilitate the collection of current. Function of brush is to just to facilitate the collection of current from armature, indirectly from armature conductor. Okay, a middle one is shaft. So these are the construction of DC machine. Okay, you just imagine. Okay, this is like this, so that accordingly lines are from north pole to south pole. Okay, and middle one which is rotating, that is armature core. While armature is rotating, this is rotating along with the commutator. So commutator is fixed to the armature. Our DC supply माने कौन? Only plus minus रहिबो. AC रहेला alternating in nature. DC means only plus minus. तो हमने higher potential, lower potential. That's why I mentioned here plus minus. You see below yoke, you see positive, negative. Yes or no? So if current flow through this, okay, when a current carrying conductor placed in the magnetic field, a force will experienced by the armature conductor, as a result of which torque will develop, and gross torque developed by the armature. So in this way your electrical energy is converted to mechanical energy. Eta motor working principle hela, working principle of motor. Okay, this is an energy conversion device, electrical energy converted to mechanical energy. Clear? So accordingly we can take the different parts of DC machine. Okay, here mentioned a DC machine consists of the following main parts. Yoke. Yoke कौन लिखा है? It is the outer cylindrical frame of the machine. Cast iron yokes are made for small machine because of cheapness, but for large machines yoke is made of fabricated steel due to huge permeability as shown in figure, and yoke serves the following purpose. Okay, तो yoke. Next कौन आसला? yoke रे कौन? Poles are fixed on it. Okay, as we discussed, okay, main poles are fixed on it. Number 2, it provides mechanical protection to the inner parts of the machine. Number 3, it provides passage for magnetic flux produced by the pole. How the flux, magnetic flux always from north pole to south pole. Okay, then come to pole. Poles consist of two main parts. One is pole core, another pole shoe. Pole core, another is pole shoe. The pole core is made of cast iron, of solid piece or cast steel. The pole core may be made of thin cast steel laminations riveted together. आम ये कौन नौचे जो कोर नौचे thin laminated iron core. Why we are choosing thin laminated iron core? Because to minimize the eddy current loss. To minimize the unwanted current or extra current, we have to prefer thin laminated iron core. Okay. Pole shoe. Pole shoe. Also Khurakutunjubanga. Pole shoe means the pole shoe is laminated and is screwed to the pole face by means of countless screws. Okay. The pole serves the following purpose. It supports the field coil. It spreads out the magnetic flux in the air gap uniformly. The pole shoes have large cross section and hence reluctance of magnetic path is reduced. Then come to field coils. Field coil here you see. Then see armature winding already discussed. Armature winding means you see middle one is your armature. Armature is rotating in between pole pieces in the uniform magnetic field. Okay, these armature having two types of winding. One is your lap winding, another wave winding. Okay. Lap winding means what? Number of parallel path equal to number of poles. The windings are wound over the armature core. Okay, windings are wound over the armature core. Generally, two types of winding preferred. One is your lap winding, another wave winding. Lap winding means always number of parallel path equals to number of pole. A equals to P. But wave winding means number of parallel path is always 2. Okay. In lap winding, the conductors are connected in such a way that number of parallel path are equal to the number of poles. A equals to P. Then one is your lap winding, another is your wave winding. Okay. Lap winding is number of parallel path equals to number of poles. Wave winding is number of parallel path is always 2. Okay. Then come to armature. Armature you see figure 4.40. Figure 4.40. All of you see. Figure 4.40. Abhishek Behra mechanical. Abhishek. देवाशीष बेहरा अभिषेक चित्रटा देखि पारछ आर्मेचर केते नंबर फिगर अछि
सर 4.39
4.40 ना ता तळकु चला
हां यस सर
4.39 टा आर्मेचर वाइंडिंग माने वाइंडिंग टा केमिति होय जो गुडा हेनी की ओके वाउंड लाइक दिस हैं किंतु ता तळकु चला माने इधर भले की बुझी हम यहाँ है आर्मेचर कोर आर्मेचर कोर माने जो मोटर मझीटा जोटा बुलूनी दैट इज योर आर्मेचर कोर आर यू गेटिंग माय पॉइंट मिडिल वन इज द आर्मेचर आर्मेचर को कौन कहि परिया हमें आर्मेचर इज द रोटेटिंग पार्ट ऑफ डीसी मशीन बुझीगला अभिषेक आर्मेचर इज द रोटेटिंग पार्ट ऑफ डीसी मशीन सजन कुमार सजन
yes sir
armature what is armature
armature is a rotating part sir
armature is the rotating part of DC machine Now we are discussing about DC machine, not AC machine. Okay.
Yes.
So in DC machine, middle one is rotating, that is known as armature. Okay, and this armature here you see, these are okay slotted thin laminated iron core. Okay, each thin lamination finally connected in form of cylindrical structure. So in figure 4.40, whatever that you are observing, okay, here you see this is armature, these are the windings, and commutator is fixed to the armature. Commutator is fixed to the armature. That means while armature is rotating, commutator is rotating along with the armature. Sajan Kumar, clear?
Yes, sir.
While armature is rotating, commutator is rotating along with the armature. And this is the shaft. Middle one we can say shaft of the armature. Okay, and these are the slotted armature. Slotted means, have you seen duster? Duster you see in the classroom for erasing, duster.
Yes, sir. Yes, sir.
Okay, so you can find a gap in the duster while the teachers are erasing, okay, for keeping. So that gap,
Yes, sir.
that means your slots are like this. Okay, so that conductors must be properly insulated. Conductors must be properly insulated and put over the armature slot. Are you imagine? Conductors, copper conductors must be properly insulated. Okay, over conductor you have to wound over some insulating material. Okay, and you have to put in the armature slots. Okay, so these are the slots. Now you just imagine from this how we'll do the, you see the binding wire. We have to wound over, okay, conductors. Okay, these are the windings are wound over the armature slots. Okay, these must be properly insulated and put over the armature slot. Okay, and after completion of the winding, that may be lap winding or wave winding. Okay, we have to put in Elmo varnish. Why will you put in the varnish? Because that will be fixed. Okay, we have to do the winding over the armature slots. Okay, and this should not be displaced. Whenever this will rotate with certain speed in RPM, okay, no conductors should displace from each other from the slot. So that means, okay, this must be properly insulated, and we can use also bamboo stick, some bamboo stick, etc. We can, okay, put. You see the slot like this here, laminated. Figure B, armature core. Armature core you see the slots, जो gap जो रहो, these are the gap. These we can say slotted armature. Over the slotted armature, windings are wound over the armature core. Okay, and for completing the gap, we can also use bamboo stick, etc. Bamboo, you know, bamboo, Sagarika Swai.
ଆଜ୍ଞା ସାର୍।
ତମ ଏରିଆରେ ବାଉଁଶ ଅଛି, ବାଉଁଶ नो you know bamboo.
ଆଜ୍ଞା ସାର୍। ଆଜ୍ଞା ସାର୍।
That bamboo stick, okay, that treated as insulating material. Okay, after winding, wound over the armature core. Windings must be properly insulated. Suppose this pen, okay, this pen is a conductor. This must be properly insulated. ଯେମିତି ଆମର ଏଇ ଯେଉଁ ଇନ୍ସୁଲେଟିଂ ୱେୟାର ନୁହଁ, PVC ୱେୟାର, PVC, polyvinyl chloride, this is a insulating. ଆମ ତମ ଘରେ ଯେଉଁ at your home, the wire that you are using, okay, तुम ताको हाथ धरला शॉक मारुचु कि नो शॉक व्हाई बिकॉज सम इंसुलेटिंग मटेरियल इज देयर yes or no so likewise the conductors must be properly insulated and put over the armature slots and being this will rotate in order to this should not be displaced so we can keep some bamboo stick okay you do the hammering okay bamboo stick se gap re pura fix he gala okay so and finally you can put in the elmo varnish varnish रे आम बुड़े देले कौन हम तार फिक्स हो गला सो once that will fix so when your armature will rotate no chance of displacement of the wire no chance of displacement of the conductors armature conductors okay so you just imagine figure 4.44a and 4.440b armature this is armature core okay so while this armature is rotating in between pole pieces so emf can induce emf can be induced by two ways either keeping field system constant armature rotating or vice versa in case of generator okay in case of dc generator your armature is rotating and field systems are constant in the figure 4.35b you see your middle one is rotating figure 4.35b okay Piyush Kumar Piyush
Yes, sir.
your middle one is rotating armature is rotating but pole pieces are constant so what we can say here the field system is stationary but armature is rotating once armature will be rotated in between pole pieces okay according to Faraday's laws of electromagnetic induction emf will be generated we know rate of change of flux directly proportional to emf induced so every time flux linkage with the coil change yes or no so this is the working principle of a dc machine okay 4.36 you see function of yoke you see here there is no armature only yoke is there okay outer frame okay how these are fixed just like in your electrical laboratory and this is terminal box for wire connecting wire okay and this is figure 4.37 pole core and pole shoe like this these are the laminated pole core pole shoe okay why laminated to minimize eddy current loss to minimize eddy current loss we are using thin laminated iron core clear to minimize eddy current losses okay we have to make it thin laminated iron core we have to prefer okay and we have to use the material okay core is made of which material silicon steel having low hysteresis coefficient last class we have discussed okay because iron loss or core loss can be subdivided in two class one is your hysteresis loss another eddy current loss to minimize hysteresis loss we have to choose the material that is silicon steel having low hysteresis coefficient similarly to minimize eddy current loss we have to choose thin laminated iron core you see how the pole shoe are thin laminated 4.37 pole core pole shoe okay इप्सिता देखियो जी
आज्ञा सर
ये जो फील्ड कॉइलटा 4.38 देखिल वेयर एंड्स आर देयर दिस इज फील्ड वाइंडिंग ओके ये कहते माने थाक थाक हो रही तमाने इच आम जदि तुम खातार जदि पेपर को देखा ताले कौन हम माने गोटे पेपर रे व्हाट एवर द करंट फ्लो आउ गोटे पेपर को से करंट जीवनी केमिति हेबनी सो दैट इन बिटवीन टू पेपर सम थिन लैमिनेशन मस्ट बी देयर माने इन्सुलेटिंग मटेरियल मस्ट बी देयर आम जब इन्सुलेटिंग मटेरियल दे देबा ताले कौन हम करंट फ्लो थ्रू दिस पेपर विल बी कन्फाइंड दिस नो करंट फ्लो थ्रू दैट पेपर yes or no so similarly here we are using thin laminated iron core okay clear all of you so these are the basic construction okay and different parts of DC machine okay and another here is a commutator 4.8.4 commutator लिखाई commutator माने कौन commutator means 4.40 you see commutator armature winding पर आउ गोटे commutator अच्छी commutator means what commutator is fixed to the armature you try to imagine Ipsita you try to imagine this construction commutator is fixed to the armature these are arranged in such way that this is fixed to the armature so while armature is rotating means commutator is rotating along with the armature hela commutator माने कौन commutator is a drop thrust copper segment each must be insulated from each other by mica insulation commutator it is a drop thrust copper segment each must be insulated from each other by mica insulation देखो अपर जो आर्मेचर वाइंडिंग दिस द बिगर वन बट कम्यूटेटर इन कंपैरिजन आर्मेचर स्मॉलर वन और नॉट इटा स्मॉल ना नहीं कम्यूटेटर आर्मेचर देखो बड़टा अच्छे बिगर वन बट कम्यूटेटर इज स्मॉलर वन
Yes.
okay if commutator is smaller one so if you take all the winding and connect it to the commutator there may be the chance of short circuit yes or no there may be chance of short circuit okay so to avoid that okay so these must be so what we say commutator is drop thrust copper segment each must be insulated from each other by mica insulation mica is a strong insulating material okay so whatever the current flow through this that current cannot flow through the other because in between mica insulating material is there and commutator you can find here you see is on figure 4.35b again you see 4.35b all of you go to 4.35b okay ये जो shaft लिखाई छी what mentioned shaft and above which mentioned brush and brush means the black color brush is a carbon brush is made up of carbon and this is your brush holder brushes can be kept in a brush holder okay and your commutator okay commutator you see the smaller one okay above the shaft the round shaft that is your commutator okay very smaller one gaps are there in comparison to armature this is very smaller one round circle okay so each gap must be insulated by mica insulation and brushes are what here function of brush is just to collection of current from commutator function of brush is just to collect current from commutator function of brush is just to felicitation of collection of current from commutator that means indirectly from armature okay so likewise you have to imagine okay and if you are having any doubt again you can put in the Google so that you can find the video lectures are there okay so this is your commutator and brush holder you come 4.8.5. Okay, after figure 4.41, figure 4.41, sectional view of commutator. You see commutator you can find like this, 4.41a, figure 4.41a commutator. Piyush Kumar, you see, okay, commutator.
Yes,
figure 4.41a. Sajan, 4.41a.
Yes, sir. Yes, sir. Yes,
You
sir.
try to imagine this. Okay, this is your commutator.
Yes, sir.
How you the gaps are
Yes,
very
sir.
small. Gaps are you see very small, and above which we can put the brush. Brush means, brush is not your dantagasa brush. Your, that is your not your teeth brush. This is your carbon brush. Okay, and this is made of carbon. Okay, whose function is just to felicitation of collection of current from commutator indirectly from armature. Yes or no? And this commutator is fixed to the armature. You imagine like this. Okay. Then some bearing arrangements are there, brush bearing, because you see if bearing arrangement is not there, so how that will rotate? Yes or no? Cycle ball bearing is there, motorcycle ball bearing arrangements are there. Okay. And another is shaft. Shaft is made of mild steel with a maximum braking strength. Okay. Then come to back EMF or counter EMF. EMF
सर
in
माइका इंस्टॉलेशन का कौन
कौन कहल? हाँ यस,
माइका इंसुलेशन
माइकाटा गोटे स्ट्रंगर इन्सुलेटिंग मटेरियल. माने देख दीटा भितर गैप वेरी स्मॉल. We have to connect the insulating, we have to put the insulating material such a way that whatever the current flow this side, that current cannot flow through that side. माने very, okay, some insulating material, just like wood. Wood is insulating material, glass is insulating material, your PVC, polyvinyl chloride, PVC is insulating material. ସେଥିପାଇଁ ଏଇଟା ଗୋଟେ ଇନ୍ସୁଲେଟିଂ ମେଟେରିଆଲ ମାଇକା ହେଲା. bricks like, okay, color you can find like this. You just imagine, then briefly higher study ର କଲେ ତୁମେ ସେଟା ପଢ଼ିବ ହେଲା. ତେଣୁ ଏବେ ବ୍ୟାକ୍ EMF କ'ଣ, କାଉଣ୍ଟର EMF. What is back EMF? Back EMF, here you see figure 4.43. All of you see figure 4.43. This is very very important. Figure 4.43, all of you see. आज यहाँ 5-10 minutes extra class नहीं कि सार दवा बुझल. Then you will revision, and after that if you are having any doubt you can ask me. Okay. So here you see figure 4.43, all of you see. चिन्मय प्रधान, चिन्मय, भवानी शंकर बड़, भवानी, अभिषेक आचार्य, सागरिका स्वाई, साजन कुमार.
Yes, sir.
Okay. Now you go through this figure 4.43.
Yes, sir. DC shunt wound motor, sir.
Yes, DC shunt wound motor. Okay. You see, this is
Yes.
the equivalent circuit of a DC shunt motor. Are you getting my point? This is the equivalent
Yes, sir.
circuit of a DC shunt motor. You see, we have already discussed that motor means what? DC motor is a dynamo. Okay. DC machine is such type of dynamo by which electrical energy converted to mechanical energy. That is a DC motor. This is a energy conversion device where electrical energy converted to mechanical energy. This is known as DC motor. Okay. So here you see this is the equivalent circuit of DC machine. Okay. Now we are supplying, this is supply voltage, here V is the supply voltage. Due to the supply voltage, current flow through, so this is your line current. IL here means line current. बुझी होची इप्सिता, एटा हला लाइन करंट. ओके,
ଆଜ୍ଞା ସାର୍।
लाइन करंट देख जाएगी ए पॉइंट रे, एट दिस पॉइंट सम करंट फ्लो थ्रू आर्मेचर, सो IA. another current flowing through the shunt field winding, so ISH. Are you getting my point? One current IA, another ISH. ISH means, ISH current is the shunt current flow through the field winding. Can amar dekho, the field winding having n number of turns, I amount of current flowing. Otherwise, how MMF will produce? Yes or no? So similarly, here field pole having n number of turns and I amount of current flowing. Why this is known as shunt wound? Because field winding connected in parallel with armature. ये जो field winding टा connected in parallel with the armature. Clear? एबे देखो armature, armature माने कौन? इटा हेले देखो due to supply voltage, इटा देखो downward अच्छी arrow direction. But whatever the EMF induced in armature, which is indirect opposition to the applied voltage due to Lenz's law. Are you getting my point? आमर गोटे Lenz's law अच्छी, LENZS, Lenz's law, Lenz's law पढ़ी चो? Have you studied Lenz's law? Due to the supply voltage, whatever the EMF induced in armature, which is indirect opposition to the applied voltage, this is known as back EMF. Okay, so EMF of rotation in case of machine, in case of DC motor, we can say EB. Okay, so whatever the EMF induced here, which is indirect opposition to the applied voltage V. Okay, so here we can take, here line current equals to armature current plus shunt current. Here field winding resistance, shunt field resistance RSS is more, armature resistance is very less. In a laboratory you have already done, being armature resistance is less, so easily current flow through the armature. Once current will flow through the armature, so when a current carrying conductor placed in the magnetic field, so a force will experienced by the armature conductor. So torque will develop. So torque will develop. Accordingly, gross torque developed by the motor. Because here Z number of conductors are there. Armature conductor, Z number of conductors are there. So for one conductor, if torque will develop, force into perpendicular distance. Okay. Then for Z number of conductor, gross torque developed by the motor. Yes or no? So here electrical energy converted to mechanical energy. So this is the equivalent circuit of DC shunt motor. So we can write here V equals to EB plus IARA. Okay. And EMF induced, here what we can find, EB, that is P phi NZ by 60A. P phi NZ by 60A. P ta kono? P is number of pole, phi is your flux per pole, Z is total number of armature conductors, N is the number of, N ta kono? Speed in RPM. At what speed that is rotating? N is speed in RPM, revolution per minute, and A is number of parallel path. So EMF of rotation in case of motor we can say EB. Clear? EMF of rotation in case of motor we can say EB. Okay. EMF of rotation in case of motor, that is EB, which is P phi NZ by 60A. P is number of pole, phi is flux per pole in Weber, N is speed of armature in RPM, Z is the total number of armature conductors, and A is the number of parallel paths. So in DC machine, we are using two types of winding. One is your lap winding, another wave winding. Lap winding re kono number of parallel path equals to number of poles, A equals to P. But in case of wave winding, number of parallel path is always 2, A equals to 2. Okay. If denominator is less, A equals to 2, then EMF will be more. So wave winding is the advantageous point of view. If you prefer wave winding, then we will get more EMF. But if you get lap winding, if you prefer lap winding means what? A equals to P, number of parallel paths equals to number of poles. Then we can find less EMF. Okay. So these are all about your back EMF. Okay. So how to write the EMF equation of DC machine? Okay. So we can write V equals to EB plus IAR. Okay. So voltage equation of DC motor we can write, that is V equals to EB plus IAR. You see, voltage equation of DC motor 4.8.9, voltage equation of DC motor. Figure 4.44, DC shunt motor you see. Why this is known as DC shunt motor? Because field winding is connected in parallel with armature. So this is known as DC shunt motor. Okay. Here line current equals to armature current plus shunt current. Here A mentioned means what? This is armature winding. FFF means field winding. In our laboratory class, basic electrical engineering lab class, we have already studied in the panel board mentioned A, FFF. Mentioned or not?
Yes, sir.
Mention ଅଛି ତ? ସୌରଭ ମହାନ୍ତି, ଜ୍ୟୋତି ଅମୃତ,
Yes, sir.
ମେନସନ୍ ଅଛି ନା ନାହିଁ ପ୍ୟାନେଲ ବୋର୍ଡ଼ରେ? ଏ ଏଫ୍ ଏଫ୍ ଏଫ୍।
Yes, sir. Yes, sir.
ତେଣୁ ସେଇଥିପାଇଁ ଆମେ ଦ୍ୟାଟ୍ସ ୱାଇ वी आर राइटिंग दिस मेंशनिंग एफ एफ एफ. एफ 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 means what? This is field winding. Okay. And A means this is your armature terminal. Okay. And current flow due to the supply voltage, this is known as line current. So line current equals to armature current plus shunt current. Okay. So come to the EMF equation, V equals to EB plus IR. V टा कौन अप्लाई वोल्टेज, EB is your back EMF, IA is your armature current, RA is your armature resistance. Okay. So if we multiply IA in both sides of the equation, ताले VIA equals to EBIA plus IA square RA. ताले VIA माने कौन? Electrical input to the armature. VIA means electrical input to the armature. EBIA means electrical equivalent of mechanical power developed by the armature. IA square RA is your armature copper loss. Okay. So we can find that is electrical input equals to electrical equivalent of mechanical power developed by the armature, that is EBIA plus armature copper loss. Input equals to output plus losses. Okay. It's already mentioned. This is known as the power equation of DC motor. VI is electrical power supplied to the armature. EBIA टा कौन लिखा है? What is EBIA? Roshan Kumar. EBIA what written? Who can say EBIA?
Sir, electric equivalent of mechanical power development in temperature.
Yes. EBIA means electrical equivalent of mechanical power developed in the armature. Because due to the supply voltage, okay, whatever the EMF induced in armature and due to IA amount current flowing through that, so EBIA. So we can say due to electrical input to the armature, okay, electrical equivalent of mechanical power developed by the armature. That is your output. Yes or no? Another is armature copper loss. So always we can find input equals to output plus losses. In our practical life, day to day life, what we can find? Always electrical, our input equals to output plus losses. Likewise here we are getting electrical input equals to electrical equivalent of mechanical power developed by the armature plus armature copper loss. Okay. Okay, after this problem we will conclude. You see, example is given, the armature of a DC motor. You read this. प्रत्याशा प्रत्याशा अच्छी के पढ़ो पढ़ वन ऑफ यू रीड रोशन कुमार साजन कुमार
Yes, sir.
You read this example
Yes, sir. Of
4.10.
course, sir. Yes, sir. So the armature of a DC motor has a resistance of 0.1 ohm and it's connected to 230 volt supply. Calculate the value of back EMF if the motor is taking an armature current of 60 ampere.
Okay, so what given here, the armature of a DC motor has a resistance of 0.1 ohm. Okay, so 0.1 is your armature resistance. Okay, generally in a DC machine armature resistance is very less than 1 ohm. Okay, and your field resistance is more. Okay, suppose field resistance is 150 ohm but armature resistance is less than 1. Okay, why armature resistance is less? Because current can flow through that easily. Yes or no? Because from the principle we know, when a current carrying conductor placed in the magnetic field, a force will experienced by the armature conductor, and for Z number of conductor, gross torque developed by the motor, electrical energy finally converted to mechanical energy. So accordingly here armature resistance is given 0.1 ohm, applied voltage is given 230 volt, armature current given 60 ampere. We know the relation, okay, for a shunt motor V equals to EB plus IARA. What is V? Supply voltage. What is EB? EB is the back EMF or counter EMF. Why this is known as counter EMF? Sajan Kumar, why this is known as counter EMF? Because whatever the
Yes,
EMF
sir.
induced in armature due to the supply voltage, whatever the EMF induced in armature, which is in direct opposition to the applied voltage. That's why the name called so back EMF or counter EMF. Okay. So we can write V equals to EB plus IRA, or EB will be V minus IRA. So value of V, supply voltage is given 230 volt, armature current given 60 ampere, armature resistance 0.1. So answer will become 224 volt. Clear? If the motor is taking an armature current of 60 ampere, okay, calculate the value of back EMF. So we will get the back EMF or counter EMF. Are you clear or not?
Yes, sir.
Okay.
Yes, sir.
So these are the these easy questions will ask in exam. Because this is the last of this module, so nobody giving stress. सब सोचेंगे क्या वो हो जाएगा तो हो जाएगा एग्जाम में फेल. So you will find this type of question in exam and this carries 5 marks or 6 marks. Just put the formula and get the answer. Okay. Similarly, you try to work out these problems. Example 4.11. Okay. Any doubt you can ask me in the next class. Okay. Then we can also derive the EMF equation for DC machine. That may be generator or motor, but equation remain the same, EMF equation. That is P phi NZ by 60A. Okay, EMF equation of DC machine. Here you see, derive the EMF equation for DC machine. Okay, finally how much you are getting? P phi NZ by 60A. Okay, so you see this, and if you are having doubt you can ask me, otherwise, okay, this type of question might have asked in exam, so all of you go through this. Same equation for generator and motor, same equation, EMF equation remain the same in terms of number of pole, flux per pole. Okay, P phi NZ by 60A, 4.9 EMF equation of generator. Okay, same machine can be act as generator as well as motor. And EMF of rotation in case of motor, EB, EMF of rotation in case of generator, that is EG. What value is P phi NZ by 60A. If P is given, okay, phi is given. So example 4.13. Example 4.13 you see a 6-pole lap wound DC generator has 720 conductors. Then P is given 6 pole. Okay, 720 conductors. That means Z is given 720 conductors. Okay, flux is phi is given 80 meter milliweber. 80 milli means what? 80 into 10 to the power minus 3. Okay, per pole. So now you substitute all the value, and this is your lap wounded. Lap wounded means what? Number of armature equals to number of poles. Number of parallel path equals to number of poles. A equals to P. Okay. So now you substitute all the value. P phi NZ by 60A. Finally you can find that is 960 volt. Ipsita.
ଆଜ୍ଞା ସାର୍।
ଏଟା ବୁଝିଗଲା ନା ନାହିଁ? ଖାଲି just put the formula, get the answer. এটা actually এই जो last module रे this type of question might have asked in exam. So you go through this problem 4.13 and other problem what I discussed. Okay, so easily you can answer. Okay, this very easy question will be asked in exam. Only you have to see what type of question will be asked. Okay, you have to remember the formula. Sometimes your derivation might have asked. Okay, so now we'll conclude. Okay, you take the screenshot of the attendance and you share.
ଆଜ୍ଞା।
Okay, thank you all. Good day.
Thank you.
Okay,
Thank you, sir.
Thank you all.